Hey, who? You lost a lot of hairs.
对
Where are you in Wuhan?
，Yes，
Who?
在武汉。
在武
Dear
汉。
colleagues, good day. Good day to
Hello，
you.
尤里。
Nice to meet you. all. Thanks.
Good morning. Nice to see you.
Good morning.
Good morning. You know, I was
Good morning.
Wuhan not too long ago. Last month, 2 months ago.
可以开始了吧，张老师？可以开始了，张老师。
1 minute left.
Vadim. Можно начинать.
Yeah.
Vadim, давайте.
We may start. Yeah, for sure.
Yeah.
Okay. So, good morning, dear colleagues, researchers, and guests. It's my great pleasure to welcome you to a sixth international conference on the artificial intelligence and logistic engineering. This year, this conference held in the online format. We are gathered here in order to share recent advances, exchange the ideas, and discuss emerging challenges in the intersection of the artificial intelligence on modern logistics system as well. This field continues to evolve rapidly, shaping now how we organize, optimize the supply chains, transportation network, and intelligent decision-making process as well. So, I would like to thank all the authors for their valuable contribution, the program committee for the diligent review work, and all the participants for joining us from different parts of the world. I hope this conference will be both intellectually stimulating and productive, fostering new collaboration and research direction as well. With that, I wish you and all for the guests, all for the authors, a successful conference. I look forward to your engaging presentation and discussion. Thank you very much for possibility to open the conference.
Thank you.
Thank you.
张老师。
So I would like to take a floor for the Mr. Junk, Professor Junk, Katie Junk.
Okay. Hello, ladies and gentlemen. Welcome to the conference, the sixth International Conference on Artificial Intelligence and Logistic Engineering, abbreviated as ICAILE 2026. Today, the opening day of our ICAILE 2026 online conference is a very special day in Chinese expression. The date in 6th day of the 6th month, the 6th day of the week, the 6th year of the 3rd decade of 21st century. In Chinese expression, 6/6, or we say double six, is a very lucky day in the mind of Chinese people. So without a doubt, the day of the opening of conference is absolutely a successful day, which will bring great harvest and happiness to all of the participants. This is a gathering of scholars from different countries and regions. It sets a platform for mutual exchange and learning. I hope everyone has a wonderful experience here. The same with all of the attendees of the conference, I am delighted to have this opportunity to gather with friends from the academic communities today to share the research achievement of each scholars and the joy they have experienced during the research process. I usually believe that it is the secondary for our international conference to publish research papers, while the more important task and the role of our conference lie in the share the research achievements of scholars in different fields, share the method used in their research, and share the experience and feelings of innovative spirit and method during the research process. In today's 21st century, in the era of intelligence, the development speed of science and technology is getting faster and faster. The dissemination of knowledge is also become increasingly rapid. International conference providers with an effective platform for sharing bring us closer and getting to know each other's better from different geographical locations. Through mutual learning, all of us can constantly grow and progress day by day. Here on the platform of conference, everyone can touch each other's research achievements, even their thoughts and concepts through the presentation and discussion. The benefits of hosting and participating in international conference are obvious. Scholars from different countries engage in extensive discussion around various scientific and technological issues, which can inspire divergent thinking and promoting unique and distinctive in-depth thinking in different directions. This is the expected outcome and role of international conferences. The exploration and academic issues at international conference can also promote cooperation among scholars. We hope to see more such collaborations. We also believe that to see as much academic collaboration continue to advance in the future, more and more technological flowers will bloom, forming a more vibrant and colorful ocean of science. It is a great honor for me to meet so many scholars and researchers through this platform of conference. I cherish this opportunity and will carefully listen to the lectures of scholars and study their experience. I hope everyone can also enjoy this process of communication. Thank you all. Have a nice weekend. That's our 2 days. Thank you.
Thank you. Thank you.
Dear Professor Zhang, thank you very much for your opening remark, for your opening speech. And now I would like to give a floor for the Professor Hu Jinbin, also for some opening remark. Please,
Hello.
you may start.
Hello, dear colleagues. Good morning. Welcome to the 6th International Conference on Artificial Intelligence and Logistics Engineering, ICAILE 2026, supported by Wuhan University of Technology, Hubei University of Technology, National Technical University of Ukraine, Huazhong University of Science and Technology, Polish Operation and System Society, Wuhan Technology and Business University, Shandong University of Finance and Economics, International Research Association of Modern Education and Computer Science. I am honored to deliver a brief opening address at this conference. I am Dr. Jinbin Hu, serving as chairman of International Research Association of Modern Education and Computer Science, ICAILE, Executive Director of International Center of Informatics and Computer Science, ICICS, Publication Chair of 6th International Conference on Artificial Intelligence and Logistics Engineering. RAMECS and ICICS serve as bridge for global scientific and cultural exchange and have organized many international conferences for research worldwide. In 2026 and beyond, our AMECS and ICICS will joint support researchers in organizing scholarly conference. Should we be interested in collaborating, please feel free to contact us at any time. We are pleased to assist you. Finally, thank you for your continued support. We encourage active participation in all conference discussion and extend our best wishes for the full success of ICAILE 2026. Thank you.
Yeah, Professor Junbin, also thank you very much for your opening speech. So I think this time we finish a so-called open ceremony. Maybe one of the presenter of after would like to add some words for the open ceremony, or we will start our first session. So our first session will start with a keynote speech. So, as I see, my proposition to give a floor for the first presenter of the keynote speeches. And first presenter will be Professor Francis Chin. As I see, Professor Francis Chin is with us here. And the presentation, development and future of deep learning. Please, I take your floor. You may start your presentation.
Okay. Thank you very much, okay, for the invitation. Let me share my screen to tell you whether we have any problems. Do you see my screen?
Yes.
Are you seeing my screen? Okay, that's good. Okay. Okay, I'm pleased to have this opportunity to give this talk to this conference. In fact, you know, when I was approached, okay, to give this talk, I was preparing a lot of materials, okay. This talk can last for 2 hours, but I was only given half an hour to do the presentation. So I will try to squeeze, okay, the material into it, okay. So I will leave something behind. Okay, the idea of this talk is, you know, that the the large language model and also AI have been developed so fast. So what I want to do today is to explore what are the basic technology and techniques to push the advancement of AI and deep learning and large language model, and also look at some future too. So I will share, since I only have a half an hour, so I will try to squeeze the material into it. Okay, so this is from NVIDIA. I like this chart very much because you talk about AI starting from 50s and then machine learning after 30 years, 80, and then right now we have deep learning. Basically, is AI, you know, in the last 10 years or so. And so for the past, okay, that was an expert system. They try to imitate human, okay, intelligence by machine. So all the knowledge are hand-designed program. And then the second stage, machine learning, is trying to pick up the features. And then the machine try to learn from the features and give the outputs. And deep learning is much better. You can skip about the hand-designed features. I mean, the machine can detect the simple feature and all the features and give the outputs. Now, the basis of deep learning is neural network. Okay, why neural network? Okay, so because neural network can model function with any function with enough complexity. I'll go through this really easily. Okay, so this is the neural network. Basically, it's inspired from the neurobiologists. Okay, it's trying to simulate the human brain. Okay, so you got neurons and also neurons and also sensors. And now this is the perceptron by Minsky, MIT. This is similar to the neuron. Okay, you have weights on each inputs, and you will get the sum of that thing. And now you can easily that we can expand this thing into multi-layers and many neurons, but you know that this remain linear, okay? Because no matter how many layers you have, how many neurons, it's still linear, and that's why MIT the Minsky think that perceptron won't do too much. But basically, because we do have activation function, the activation function is non-linear, okay? Like the sigma, 10H, and RURU, and etc. So now, because of this activation function, non-linear, we can do a lot of logic functions and or not, which I won't go through. Okay, so we can also do classification problems. For example, this is a linear separable hyperplane. Okay, we can do classification. Okay, this is the dividing line is an equation. Okay, can you see it, or am I blocking you, or what? It's okay, right? Okay, let me move this thing away. Okay, so you can see that the dividing line is a formula, and based on this formula, okay, we can construct a neural network. The neural network basically get the coefficients as the weights, and then get it done. Okay, and so we can classify 0 and 1 like this very easily. Okay, so this is two-dimensional, but for hyperplane, you have multi-dimensional. It can do the same thing, but they are linear. Then you may ask, okay, what about this non-separable data sets? For example, over here, you can see the red and the blue are not linear separable. Even, for example, something like this, okay, we can still do the classification by using and or not functions with that thing. So we can get two lines, okay, and get the classification. And we can also divide the inner circle by 3 lines too, okay? So this we can do, we know that we can do classification easily. Then what about regression? Okay, it's very common for machine learning. How can we simulate, okay, with the functions like this? Okay, it's an arbitrary function. How can we do regression? Okay, so we look at the activation function. Activation function is like a sigmoid. And then if you do the weights, a simple like this, assuming x is between 0 and 1, and then the output will really look like the sigmoid function. Okay, because when x equal to 0.5, okay, you know that when x equal to 0.5, this will be equal to 0. And then here will be 0.5 in the sigmoid function. So based on this thing, on the other hand, if we make the weights very high with the same ratio, for example, instead of -5, you got 500. Instead of 10, you got 1,000. Then you got a function like this, like a step function. And if instead of -5, 500, -400, then you can shift the step function to the left. And then you can auto scale it. We can get 0.6 to scale it down. So because of this thing, we can make a step function. Okay, this step function start with 0.4, and then later on 0.6, because you add it together, because this is negative, and so you got a step function like this. You know that based on these things, we can simulate any functions, okay, by the neural network. For example, here, I want to have a function y, function wy, so I can get negative w over here, okay, and negative w plus epsilon a little bit over here, a step function. So we can make this step function very steep, okay, like this, and any value, okay, and any y. So we can simulate any functions, okay, approximate any function with these step functions. So now That's why we want to use neural network. But it's deeper the better. Now you can see that we know that we have the very deep right now. In fact, neural network can model function with enough complexities. Okay, so look at this. Why we want to depth? This is the what? ImageNet. Okay, in the about 10 or 15 years ago, this is a big improvement. Okay, in fact, Hinton was involved in one of the AlexNet. And then you can see that the performance improved. When you get the ResNet, a few years later, you got 152 layers instead of only 8 layers at the beginning. So now the thing is the deep part network perform better? Okay, so in theory it is, but in practice it's not. Okay, in practice you find out that 56 layers have more error than the 20 layers because of what? Vanishing gradient problem. Okay, so how can we get rid of it? ResNet get a smart idea. You call it skip path. Okay, in fact, it shortened. Okay, the depth. Okay, so you make it work. You can have increased number of layers. In fact, recently, DeepSeek using the hyper connection. Okay, instead of a simple connection, he make a parallel stream like the highways. You widen this thing, so you can have changed the information. And this is come out last year. Okay, this is something for the skip graph. Now we know that we can build network with deeper and larger to simulate any complexity. But how can we build a neural network for my application? So we can train it. Basically, we train the model with backpropagation and gradient descent. So this is very important in order to make it work, the neural network. What is training? Training is assess the parameter of the neural network to give the right answer with the minimum error. So the basic idea is gradient descent. Okay, so you randomly guess an answer, and then you do the slope and gradually get to the minimum. Okay, that means the best fit. Okay, so the challenge is you got millions or billions of these parameters. How can you do this? Okay, the way you do it is the paper by backpropagation. This is a paper, an old paper, but it's very important and impact. Because without this paper, we cannot do the learning fast enough. And in fact, one of the authors is the Nobel Prize winner, okay, Jeffrey Hinton, okay. So you can see that. Now, the people also wonder, will this method, gradient descent, really give the minimum? Okay, because look at that. The function is very complicated. Millions or billions of parameters. You may have a lot of local minimas. Okay, if you do the gradient descent, he may trap in one of the local minima and cannot get out. This is a myth. But now we know that. You look at it. If we want to get the minimum, really the local minimum, all the dimensions have to go up. Okay, all the time you go anywhere, any dimension, you have to go up rather than going down. Okay, so the probability of really a local minimum is very unlikely. It's 2 to the negative n. N is the number of parameters, which is trillions. So you really, most of the time, you cannot get the local minimum. So this is a myth. So you will not be trapping on any of these things. So usually the set total point, there's some dimension you can go improve. So that's why the learning, gradient descent, and propagating works. Now, let me go further. Okay, this is the basic about neural network. But how objects are represented in deep learning? Okay, embedding is another big concept. I'm going to go through very quickly. What is embedding? Embedding is all the objects, words, documents are mapped into vector, just like this. And then, in fact, the closer those objects are closer together, have similar meaning. Okay, this is a basic idea of the embedding. In fact, Amazon use this thing for their marketing. Okay, so the customer is also a point in the space, and then all the nearby books, okay, will be given to the customer. Okay, advised to the customer. So this is the embedding. In fact, the embedding we used okay, in the deep learning or in the large language model is distributed representation. All the vectors, the element of vector represents a feature value. Okay, for example, a person is not described a person, it's described by the gender, by the age, by the race, by the height, by the weight, by etc. Okay, so in fact, this is much better than all the representation like clustering, nearness labor, because this is not distributed. Okay, so because of the vector space, the embedding you distributed, it works well. Now, embedding is the key thing. Now, what about transformer? Okay, the transformer is another key technology because it models the large language model and computer vision well using embedding. This is the paper. Attention is all you need. Okay, this is almost a 10 years old paper. Okay, you can see that all the authors except one. Okay, except one. Okay, which is still with Google. This is a Google paper. All the other went to some other startups. Okay, one went to OpenAI or etc. So you know that what is attention and embedding. Okay, so in fact, transformer give a better embedding, okay, because of attention mechanism. Look at this. The boy is holding a blue ball, okay. This ball is attached. We know that it's blue color. Is someone holding it and play by the ball. But now this is different from a dancing ball. Why? Because the context, because the attention. So in order to do that, the transformer have three parameters, or you got the query K and V. Q is you ask what you want to ask for. K is what you can offer. V is what you contribute. So we use this to learn this thing, and so that we can get meaning to each. Meaning, the attention mechanism will give a contextual embedding. That means the embedding is not in the vector points, but will be dependent on the context. But that's not only, that's a lot of embedding like this. But why transformer can perform so well? Because the embedded size is variable. You look at all the RNN or LSTM, the state vector is fixed. But in transformer, the embed size depends on the inputs. So you got larger input, you got more, the embedding will be larger. And moreover, you don't like the RNN, okay? If they are separate apart, you take longer time to get the information at this distance independent, because the attention get it at the same time. Parallel probe at the same time together, no matter how distant they are. Okay, so transformer really perform well. Okay, in get a good embedding, which is important. Okay, for the mechanism. Now, another thing is why ChatGPT LM perform so well. You know that about a few years ago, ChatGPT come up, everyone got alarm. Okay, because the performance is so amazing. Because the big model size matters. This is another key observation or key technology, because you need to have a big size. That's why you have large language model. We have emergent abilities, which small model would not have it. You only have it when you have a large model. Okay, so look at this. This is the model size. The X is the model size. And this is the performance. For example, this is accuracy. Okay, and this is accept match or not. Okay, and this is true and false. Okay, question and answer, the accuracy. And you know that the performance almost not improved so much, but you have up to a certain point, it suddenly improved. Okay, the performance improved so much, not only for arithmetic, for any problems. Okay, for multitask, for gram mapping and everything. When the machine go to a certain size, the performance erupt. And that's why we have large language model. You only happen when this is large enough. And that's why there's no secret. Okay, in fact, you look at that. After the announcement of the ChatGPT, everyone Okay, for example, DeepSeek, Quen, and also Alibaba, Tencent, they can follow it because no secret, not like the chip, okay, not like solid states, okay, making chips. You have the non-neutrality. Here is everyone know that you can make large enough, then this ability will show up. And that's why now we have large language model, and this is no secret. Now let me look at DeepSeek. I think I will not go into it, but DeepSeek use a mixed experts, okay, of pre-training instead of the multi-layers perceptron, okay, because before it was a fully connected network, which is a fully connected, but using mixed experts is more efficient and can do the same performance, and that's why it's more helpful. And supervised fine-tuning, okay, the fine-tuning they use reinforcement learning, a rule-based reward, rather than using a lot of data. Okay, this is another technique, and also network distillation. Okay, they can use a smaller model, okay, and to the same performance a big model. Then you may ask, what is a network distillation? In fact, for example, this is a real function. Okay, I got a small model. A small model is only a linear. So this is the data point I got. So this is a small model. This is what I got to approximate this complicated model. But now what about distillation? Distillation is I train another model, okay, which try to do better job than this small model. So this is the green one is a large model, a larger model, which do better than the small model. So this look like a tutor. It's not a teacher, but a tutor. And then the student is trying to learn from the tutor rather than from the teacher because the teacher is too busy or too complicated. So they got more points, data point from this tutor. Okay. And then the student learn better and got a better results. Okay. That is the network distillation. Okay. You train a smaller model to produce the same output as a large model. Okay. So even though he may not, okay, he will do better. Now I will go through them. These are key technologies. Okay. Recently, all the vision or images, they're using diffusion. Diffusion in physics is things that spread out in a stable manner, just like a drop of ink in the glass of water. You can easily spread out and you cannot identify the drop of ink. Okay, so diffusion is amazing too. It's like that. Okay, you got an image, you add noise to it, eventually you got only noise. And from the noise, you want to take out the noise and you can get the data, the image again. Okay, this is working amazingly well. Okay, and stable diffusion usually from a text to image AI model to create image. Okay, by the text description. You may ask, why not use GAN? GAN have been used for many years. GAN also use a random noise and produce a picture. Okay, it's doing the same thing. I got a random picture and then go to the image. But why have you use diffusion? Why not GAN? In fact, diffusion is a stack of GANs. Okay, because if I do GAN, I want to do this in one step. This is difficult. Okay, that's why it's not performance is good, but it take a lot of training. But the diffusion is they make a small perturbation at each step, and it's tractable instead of a single function. So the diffusion model predicts what the noise we're going to remove. Okay, so this is the what? For example, my text is avocado armchair. So this is the noise. Okay, let me see. Where's my pointer? Oh, I don't know. Oh, here. Okay, so this is the noise. I got a training a neural network. I predict the noise. Okay, and then subtract it. And then loop this thing many times. And then eventually I will get the image. The right, which is according to the avocado armchair. So diffusion is also one of the key things. Let me see what the time. Okay. Am I okay? I'm doing very fast, right? Am I? Okay, I'm on track right now. Okay. So okay, now let me look at. I think I'm doing maybe a little bit too rush. Okay, now we talk about all the technologies. Okay, it's very, I mean, quite technical. If you have no background, you may have difficulty. Now let me go to the future. Okay, the future is we want to have AGI. Okay, we are talking about human intelligence or general AI. Okay, so when we will have it, we do not have it right now, but when we will have it, okay. So we try to survey a lot of IT experts, ask them. They are on the field. They know, okay, when we have AGI, human intelligence. Okay, so you start with what? Early in the 20s, 10 or 20 years ago, they say that, oh, 80 years or more. And then later on, when GDP come out, they got 50 years. They say that, oh, now it's doing so well. We can do it maybe in 50 years. But when Llama 2 and GPT come out, they say that these experts predict that will be much faster, 18 years. Okay, when GPT-4 come out, now it's taking 8 years. 8 years, that means in the 30s, we will have it. In the 2020 or 2035, we will have it. Okay, so you can see that, okay, that all depends on the slope. But now we know that AGI is coming. Okay, now, how can we bench AGI? Okay, how can we, what is AGI? What is the general intelligence? All the job, for example, neural network AI can do well with any task-specific skill. This is not intelligence. For example, look at Go game. Go game. I mean the AlphaGo. The AlphaGo, deep mind make it. Okay. So this is only a search. Okay, only faster search to find the solution. It's not intelligence. For example, data training, LLM, they are memorizing it, maybe doing slightly generalization. It's only search and memorization. Any task, specific skill, okay, or ChatGPT or anything like that is not intelligent. Then what is intelligence? What is AGI? I like this code very much. Okay, Jean Duquette, okay, Pierre Get. I don't know how to pronounce that thing, okay. This is French or not. This is the father of developmental psychology. He say that intelligence is what you use when you don't know what to do. I like that very much, okay. Intelligence is what you use when you don't know what to do. When you don't know what to do, then you use it, and that's intelligence. So how can we test intelligence? We have Turing test for the intelligence, but already passed a long time ago. So, and you have exam test, okay, for example, law and everything, the measurement of that thing. You have Q&A and all those things. They are all just like that. It's task-specific skill, okay? Even when it's not intelligence. So what this is called the abstraction and reasoning corpus, ARC. Is the AGI benchmark. What you do is you look at this. You look at this picture. You look at this picture. You look at this picture. Now you say that what does the picture come up? Oh, for human, you can see that, oh, this will be the same over here, except that all the encoded region will be yellow. Now you can see that. That is the answer. But for this is one of the methods. You got many of these puzzles. Okay, for doing this thing, the best AI system can only do 34%. Okay, human can do much better than that thing. Okay, why? And then in fact, they have $1 million prize. You can beat the human. Okay, on that thing. So you can see that this is one of the measures for the AGI. Okay, now let me go to, okay, this is AGI coming, you know that. Now let's go to, everyone say that AI is not explainable. So sorry, something coming in. Okay, I'll shut it up. Okay, so explainable AI. This is anything coming up. For example, this is a black box. You know the ImageNet. Okay, you give what do you do? You train it. You train it with many pictures, and then you go to a model. You do have a model right now. You learned already. Now when you got a picture coming in, and then it will tell you, this is the cat. This is end-to-end, okay, ImageNet. But you may ask, why did you do this? Why not something else? Okay. When do you fail? Can I trust your results? There's no explanation. Okay, on this thing. It just gives the result, the probability 93% is a cat. Now we want to have an explainable AI. How can we do it? It's coming. What you do is, you need another layer here. In fact, it's not difficult. You know the GF net in the after the AlexNet, they try to study what each of the purpose of each neuron. Okay, so what you need is, here you got an interface. When you're doing this thing, you know that this is what explainable model. Here, each of these neuron represents some meaning. Okay, so you will answer whether this is an animal, because in the neuron you have this all information. Do you have a fur? Do you have a whisker? Do you have a claw? And then based on this thing, then I can deduce that it's a cat. So now I can explain to you. Okay, before you don't have it. Right now I can explain to you. Because this is you have fur, you have claw, and because of all these features, that's why it's called a cat. Okay, this is a layer which it will be added. Is it difficult? Not difficult, because all the information are already here. You just try to get the information, what this neuron represents, the features. And in fact, the GFNet, okay, in many ago after AlexNet already done some part of it already, but this is a further thing. Now, another aspect is personal vector. Okay, what is this? This is quite a recent work too. Okay, last year, something like that, is from Austin and Berkeley. What it does is, people have personal characters. Some people are evil. Okay, some people are honest. Okay, for example, some people are fancy. That means always please people. Okay, try to accommodate it. Some are humor, some are optimism. Okay, some are very depression or anything like that. But what about neural network? Do we have something like this? Yes. We do have a personal vector. We have a slider, a scale. Okay, when we push the scale up, okay, the AI will sound malicious, is evil, bad. Okay, for example, when we push the circumference up, the AI will tell you what you want to hear. Even it's wrong, he want to please you. So right now, we do have a personal vector. Personal vector is basically have the character. Do we have, is it important to have? Yes. Okay, we can train, we can model our LLM or anything like that to have certain characteristics. How this done? This can be done easily because they got techniques. That's why in the paper they measure it, certain slider, certain neurons or a certain group of neurons indication on that thing. Now, this is something I want to also the people want to in the future want to ask. Does LLM have the reasoning capacity? Can LLM really reason or just memorization? Okay, that means it's kind of intelligence or just is a fast search. Okay, like this. Now, what is a reasoning? Now we have reasoning model. You know that the LLM is reasoning model. They use what? Chain of thought. Okay, all this chain of thought is not in reasoning. It's not intelligence. Why chain of thought is coming up? You just tell the machine, you follow this path, then you will get the answer. This is going to improve sampling efficiency so that you can don't have many mistakes. You have a fewer try to solve a problem. Okay, this is what they call reasoning. It's not reasoning. It's for the efficiency. In fact, we have two models. One is a reasoning model, one is a non-reasoning model. Okay, will you let the model run a long time? Okay, just try to get the answer right a long time. Many trials, okay, many tries. You find out that the non-reasoning model doing better than the reasoning model. The non-reasoning model can solve more reasoning problem than the reasoning model. Why is like this? Because the non-reasoning, they do have any guidance. It's just exploration. In fact, the reasoning model is doing worse because already they give him a track where to go to. So you can see that the reasoning model with no reasoning capacity is not reasoning model, no reasoning capacity, sacrifice, okay, the border reasoning capacity for the sampling efficiency. He only want to set a narrow sampling, not exploration. Not exploration. That is something not good, okay? So, in fact, recently, we found out that this is a cooking phenomenon. It's a new thing. It's very, very surprising. You know that when we are going to do training, you overfit. You overfit. When you overfit, you can see that here, the training error, this is accuracy, okay? Or this accuracy. The accuracy is getting better and better. But the validation, in fact, you go up and doing down again, okay, because you overfit. But when you train a long time, keep on training like this, even though this is overfit, you train a long time, suddenly the performance improve. This is called crooking. This is a new phenomenon, recently discovered. Okay, when you long after the normal overfitting, the model start to improve again and have extreme generalization capacity. Why is like this? Because when you're doing the overfitting, what you do is you have, for example, using regularization. You keep on training it, the regularization error, you will fix, don't move. And then you eventually will train the other parts. Okay, and then when you train the other parts, then you got a generalization like this. And this is a phenomenon, and the people are going to look into it, okay, whether we can have a really reasoning model. Okay. Right now, I think I'm going, I leave almost the time for me to leave, okay? I spent more than half an hour already. Okay, augmented intelligence. Okay, right now, AI always compare. Okay, let me see, compare with human. Okay, whether you can do as good as human. Okay, for example, law examinations or doing a Go game, all these things, solving these problems, you compare human. But in fact, this is not a good measure. Because the intelligence, this is using AI is only a collaborative tool. Okay, it's not a standalone machine. We don't want to have a standalone machine. We don't want to have a machine to replace human, to replace us. We want it to help us. Okay, so the measure is how good you can help us. It's not how good it can do standalone. These are wrong measures. Okay, for example, when we have mouse, the mouse is a very efficient tool to help us to do the cursing or something like this. Means we want to augment human capacity rather than replacing them. So all the measures are wrong. Okay, we should use how to make AI as a collaborative tool rather than standard machines. We want to a human-centric partnership. not total replacement. I think that's all I want to talk about. Okay, I think I spent more than half an hour, and thank you for the patience. Is there any question and answers? Okay.
Okay, thank you very much for your presentation. And may I ask you one question?
Yes.
And my question will be devoted to some problem about so-called human level intelligence. Can the deep learning reach the human level intelligence in the future? Maybe
Yes.
in the
Okay. You know, that's a chart, okay? I'm not a prophet. I cannot predict that thing. But as I say that, when you ask all the AI experts, okay, they got a group, whatever, they ask them, when we will have really general AI, okay? And this is what they predict, okay? Okay, now we think that we will have this kind of intelligence in about a few years later on, okay? In fact, the people are also very optimistic. They may have super AI, not even equal to human, even better than human. Okay, for example, you look at it, okay, right now, for particular task, the machine already have done better than human. For example, Go game, okay. For example, the ChatGPT, you're already doing better than human. Okay, for sure you have hallucination, but they can be a little soft, okay. You can, because the machine can read many books, can digest all these things, okay, already doing better than the human already. But what about reasoning? That's why I mentioned that. I think that eventually, from my point of view, we will have the machine will take over human. But on the other hand, I'm also very conscious. I think it's not only me. For example, Elon Musk, okay, or many people, they are really conscious, okay, that is a box of Panado box. We do experiment, we create something we don't know, and it's dangerous. Okay, just like the biology, we can make another human being. Okay, but we won't do it because we don't know what happens. The same as AI. Right now, the people are pushing it. And that's why you can see Elon Musk and the OpenAI, they are fighting because they think that this is not the way to go. You should slow down a little bit. We have a regulation and everything like this. Because right now, deep learning, AI, we do not have the fundamental knowledge to understand it too well. Okay, we know that he performed well, but we don't understand it. Okay, that's why right now the research is experimental. Look at that. 100 years ago, the Hans brothers, they make the airplane. They fly very well. Okay, they can leave the ground for 2 minutes. But that was a breakthrough. But at that time, they don't understand fluid mechanics. They don't understand anything. And they just try to improve the airplane. They use the airplane, I mean, two wings, double wing, or even triple wings. And where is the propeller, in the front or the back? All these things, it take almost 100 years. Right now, we can understand better about fluid mechanics, wind tunnel. We can design better planes. But for the neural network, honestly, we don't know. We don't have enough theory to back up why it works so well. As I mentioned that the emergent capacity, when the large size is so large, suddenly he can perform so well. No one understands why. Okay, this is, do we have intelligence? I think that we will have that thing because we don't understand it. But do we have the control? I'm really a little bit skeptical about that thing. I'm really think that it may be too much. Okay, we will advance so much without understanding really what it's doing. Okay. Anyway, I hope I can answer your questions. Okay. Every people have different view about AI, and I have my own. Okay, and I really think that we should be more step by step. Okay, doing this thing. Okay, a lot of experts. For example, Elon Musk, okay, try to suppress OpenAI. They think that because he's jealous about AI, about OpenAI doing too well. In fact, I think that he may have some reasons. And there are many AI experts. They have a reservation about the recent advancement of AI. Okay, thank you very much. Yeah.
Chen, I have one question.
Thank
I
you
have
very
one
much.
question for you.
Okay.
Which large language model currently excel most in understanding scientific papers, particularly English language technical article? We would like to use this model for prior review of our manuscription prior to submission, systematically identifying potential issues to enhance the academic quality and increase the chance of acceptance.
I see. This is a very good question and it's a tricky question. I don't think I do have an answer for that thing, you know. I know there's a lot of work AI been helping us, okay? And that's the thing. I don't honestly, you know, I do not know the answer, okay? Which is a large language model, because no language model is really specifically trained for that thing. I think you can try a different prompt, okay? Prompt and then you may get it, you know. In fact, now AI is doing on plus X. X can be finance, can be education, can be medical, can be anything, okay? Because all these are specialized on the AI, you know. And now you want to be AI on research, okay, on reviewing paper and all those things, you know. I think you can do a better job. In fact, I'm using AI to do my, I'm teaching, okay? I'm teacher to grade my exam too. To grade my exam.
Okay,
to grade it.
we can talk about it later.
Oh, talk about it. Okay, sure. You know, because there are other. I think I'm overrun the time already. You know, but thank you very much. Any more questions, or Chairman? Yeah.
Thank you.
Any more question, please? Okay, thank you very much, dear Professor Chin, for your brilliant presentation. Thank you very much again, and for your answer for the questions.
I can the talk can be 3 hours, you know, but I squeeze it into 1.5 an hour. Okay, thank you.
Okay.
Bye.
Thank you.
Bye-bye.
Thank you again.
Yeah, I'll stop there.
And now, let me introduce the next keynote speaker. Next keynote speaker will be Yuri Ushenko. And Yuri, you are with us, as I see. And
here.
your presentation, AI-powered video analysis for the human identification and condition monitoring in extreme environments. So you may start your presentation. You have about 1.5 hours to present all your scientific details and scientific research.
Thanks a lot, dear colleagues. Do you see my screen?
Yes.
Yes.
You may start.
Yes.
Everything is good.
Okay. The next slide.
Yes.
Yes, as
Okay.
well.
Okay. No problem. Thanks a lot. Thank you very much for my dear colleagues, for Professors Zhenbin Hu and Vadim Mukhin, and also organizers of this conference. So it is my pleasure to be here and to present my recent research of my group also, and to be here in this on this high quality conference, a scientific conference. So let's speak about a few words about me. I'm from Ukraine, from Yuri Fedkovich National University, and now working in Shaoxing University in China. So my report is, from my side, is very topical today. So it connected with artificial intelligence powered video analysis for human identification and condition monitoring in extreme environments, because this topic also it is very important now in all our countries. We will deal with AI methods and how it could be implemented in this condition monitoring in different extreme environments. Okay. Do you see my next slide? Oh, this one. Yeah.
Yes. Yes.
Okay. So let's speak briefly about the relevance of this problem. And so there are some modern challenges. It rises from the combat and man-made disasters to large-scale rescue operations required at this time. Automated, fast and accurate analysis of a person's conditions using a video stream, because every unnamed vehicles and drones, so they use the video stream to connect and to present the information to the operator. So there are several tasks in this problem. We can choose the military operation, rescue services, and security and monitoring. So as we talk about the military operation, the identification and assessment of the condition of personnel and wounded in combat zones with limited visibility. Due to the rescue services, there are rapid triage of victims during earthquakes, fires, landslides, and environmental disasters. Due to the security and monitoring, so about the video surveillance systems, transport monitoring, and critical infrastructure control. So in this consent, the key problem here, it's the elaboration and construction of modern systems. At this time, this modern system demonstrate about from 36 to 52 degrees in accuracy and combined action in degradation factors due to the low light, noise, some occlusion, distortion, and so on. So for us, the problem statement and main main challenges for us divided by two tasks. The task one, it's a human identification in the video stream, and task two, it's assessment of the human condition. Due to the task one, so in a poor visibility conditions, we have several tasks. So it could be low light, fog, smoke, noise, atmospheric distortion, occlusion, some partial and strong overlaps, change in closing perspective scale, intermodal gap, and domain shift in real conditions. Due to the task two, there are lesion identification and medical triage. So there are the stress, time constraints, incomplete information, noisy audio, video signals, unsynchronized data from different sources, combined injuries, bleeding, burns, fractures, and For example, also need to for a rapid triage, very important. So it could be could be divided to red, yellow, and green, and limited resources for deployment. So this mean average perception is about 50% under combined degradations. It's a baseline model. And the triage categories needs to be synchronized visually, audio, and text. So namely 3 categories. So also these slides presented impaired visibility conditions, classification and approaches that could be used during these tasks. Systematization of types of visual information degradation and compensation methods presented here. So, for example, here you can see the type of conditions, image degradations, and compensation methods. For example, for the fog and haze, due to the image degradation, we have reduced contrast, diffuse lighting, low color saturation, and as a solution, we could use the dehazing dark channel prior, CLAHE, synthetically blurred data training, or domain adaptations. In the case of smoke, firefighting, or something like that, so the high opacity, dynamic occlusion, spectral redshift, especially. So, like a compensation methods, we could use the transition to infrared or thermal channel, multimodal fusion, RGB plus IR, infrared, attention mechanism on visible zones. In the case of low light, night, or basement, so high sensor noise, low details, loss of control information. So we could use the gamma correction, histogram equalization, low light entertainments, enhancements, and near infrared illumination, thermal imaging. So in the case of rain or snow, so we will have a linear artifacts, droplets, dynamic occlusion, and glare flare. So in this case, we need to use the deep network deraining, frame-based temporal filtering, or video-based also filtering. In the overall combined conditions, so a combination of the above is the most difficult scenario in real life. So, because in this case we have different situations, and how we can combine it in one something like an expert system or something like that. So the quality-aware fusion with adaptive weighting. This model selects the processing method itself. So the key advantage of the quality-aware approach is that the model is robust and to any combination of conditions without the need for separate solution for each. So in this slide, you can see the purpose and objectives of this study. So the main purpose of this research is to develop an integrated intelligent technology that simultaneously provides robust identification of a person in video stream under pure visibility conditions and automated assessment of their conditions with medical triage in real extreme conditions. So here we have at this stage 4 stages. The first one is the analysis of degradation factors. The second one is the quality-aware methodology. The third one is a multimodal integration, and the fourth one is the experimental verification. Shortly speaking about this, that the first stage, it's the investigation of the impact of low light, noise, atmospheric distortion, and the occlusions on identification quality. The second one is to develop an adaptive mechanism for image quality assessment and weighted feature formation. The third one is a combined visual, audio, and text sensory data via transformer cross-attention. And the fourth one is quantify the proposed method compared to baseline of and SOTA approaches. So let's speak a few words about the modern methods of person re-identification. There are following direction of approaches. We have it's from a multi-granular feature to foundation models, and example of some methods there are you can see on this slide. So it's MGF INET, Dong-et-al, DRC, ReID, multitask fusion, spatiotemporal, and VIT transformer. And the increase of such using of these approaches is from 5 to 10, maximum 5 to 15%. What are the key limitations for this approaches? So it's a weakness with strong occlusion. For example, for the first one, MGIF INET requires multiple angles for occult re-ID, sensitivity to visual attributes for close changing re-ID, does not take into account combined degradations for VIS-IR cross-modality, and dependence on video quality due to the video-based re-ID, and lack of specialization to the foundation models. So the main review conclusion for these approaches, there are that modern methods provide a stable increase of 3 to 15%, but do not address the simultaneous action on several degradation factors. So, and there is unsolved problem exists that robustness of model to combine multi-factor degradation of visual information in real-world scenarios. So the next slide presents the modern approaches to overcome this, to multimodal AI in emergency medicine. So we have A, B, C, D these approaches. The A is a multimodal fusion architecture. It's a transformer-based model for image synthesis and clinical descriptions. So confidential guided fusion with incomplete data, with some limitations that are focused on hospital setting, not on the stress, time, pressure on an emergency. The B approach, it's in an NLP system for TRAGE, so natural language processing system, caused by classification of injuries by symptoms description, rapid TRAGE by dispatchers, knowledge distillation for mobile devices. But we have some limitation in this model because of dependence on completeness quality of text description. Also, the next one, it's specialized lesion models, prediction of this situation in children for fractures, deep strokes, and neuro rehabilitations. But we have here that some limitations that domain specific does not cover combined injuries. And D, it's generative diffusion methods that the latent diffusion for neuroimaging augmentations. So, and here we have some limitations due to the auxiliary methods, not decision-making tools. In our researches, and also we have proposed the unified architecture. Due to the enter, we have a video stream, audio, sensor, text, and context. So the branch 1, we propose to use the identification, and branch 2, we propose to use the condition assessments. Here we have a quality over re-ID, and branch 2, multimodal lesions ID. From the branch 1, we propose to use the first the quality model, quality score model, QI, preprocessing pipeline, feature extractions, due to the, maybe it could be YOLO version 8 and mask with recurrent CNN. Adaptive weighting, attention, also. Due to the branch 2, we could use the first data collection, visual, audio, and text. The second one is preprocessing for each modality. 3, it's a feature extraction due to using this different neural networks from CNN, VIT, and transformer. And 4, it's a transformer cross attention fusion. And the 5, it's lesion class, severity, and triage. So the data collection and preprocessing pipeline looks like on this slide, from raw video or photo to prepared feature representations. So it's going through the first, the source. It's namely data collection. It could be drones, fixed cameras, IR sensors, audio, this format. So the second one, it's a primary. So it could be frame processing, namely video stream decoding, stabilization, anti-vibration, optical distortion correction, RGB normalization. The third one, it's image quality. So it could be integral evaluation, blur plus noise plus illumination plus occlusion, level pulsification, namely pure, medium, severe degradation, and flow branching. The 4, it's adaptive pre-treatment. So it's contrast, CLHE, gamma correction, noise, median, Gaussian, denoising, fog, dehazing, dark channel prior, and augmentations. And the 5, it's conclusion, ready for the model, for example, standardized dimensions, 640 on 640, normalized tensors, metadata, and prepare input for re-ID plus lesson ID. So, and the quality aware identification, the key concept could be raised here. So, in order to the novelty of the approach, model adapts its feature weight depending on the degradation level of the input data, ensuring a stable performance in complex real world conditions. So, we have the quality score model 1, adaptive weighting 2, and attention fusion 3. So for the quality score model, we have the effect that provides a quantitative degradation score for each frame. For the second approach, we have automatic adaptation without retraining. And for the third part, we have multi-level representation of robust to distortions. So, and the main conclusion here, we have the integration of these 3 mechanisms ensure dynamic adaptation to the degradation level of the input data. So here we have experimental base and degradation modeling. So we had a data set of experimental sample structure of 800 images with these parameters. Sorry. Yeah. With several degradation modeling parameters. The Gaussian blur, here the salt and pepper noise, gamma correction, and contrast reduction from 30 to 60%. So, and here I would like to present the impact of degradation factor on the identification quality. So here we can see that this bar chart, in order to measure degradation under different observation conditions from no degradation here, the left bar chart, low light, noise, blur, atmosphere occlusion from 40 to 80% and combined factors. So, and comparison here, we have the comparison of human identification methods of different algorithms. For example, using YOLO version 8 plus RAID, MASK, RCNN, plus RAID, cross-modality, SOTA, occlusion-aware SOTA, and proposed our methods. So we have the results that proposed methods gives the 81% and 0.2 in rank 1 accuracy, for example, in 78% and 6 in MIP, and 0.8 in F1 score. So let's speak about robustness of methods to degradation factors. Here you can see the average accuracy loss. For example, for a baseline, it's up to 38%. For MASK RCNN, up to 32%. cross-modality, occlusion aware, and so. But proposed methods is up to 40%. 40%. So the conclusion here is that quality-aware fusion reduces the average accuracy loss by 2 to 3 compared with the baseline across all degradation types. So here we have the types of injuries and diagnostic features for identifications. We can use in this investigation. So multimodal lesion ID recognizes 5 lesions classes using visual, audio, and sensor features. It begins from bleeding, burns, fractures, brain injuries, and combined injuries. So, for example, here you can see the several typical class of injuries, glass bleeding, it's cut, bruise, also cut, and burn. So here attention heat maps where the model looks when identifying body lesions. So the model interpretation through attention visualization. In here we have the model activation maps on a test sample trained to identify facial areas affected by acne. What is shown in these pictures? So the first one, it's red zones. It's equal to areas the model relies on the most when identified facial lesions. Blue zones have a weak influence on the decision. And the second one, semantic consistency. So the model consistently keeps its focus on the same key areas, facial affected by a skin disease. Also, here we have the model architecture, multimodal architecture for condition assessment. It consists of visual, audio, text, and sensor information that input on the core. Core is a transformer cross attention, consisted of multi-head attention, Q, VDK, multimodal fusion, adaptive modality weights, robustness to noise. And we have on the output the classification, lesion type, bleeding, burns, fractures, TBI, combined severity of these lesions, and triage, which is most important. It combined red, yellow, and green based on the thresholds. So why cross attention strengths on this approach? So operating principle, there is the dynamic modality weighting, and the model automatically determines each modality contribution to the final prediction depending on the context. There are under heavy smoke for burns and visible injuries when consequently is lost, and under high environment noise. So this architecture advantages, the first one is adaptability to noise. The second one, interoperability. The third one, a 3-layer optimization. And the fourth one, contextual relationship. So some mathematical foundation of the proposed approach, it's part 1, quality aware RID, and transformer cross attention here. So it's really briefly, and here we have the results of model training dynamics. The left graph, you can see the loss curve. The right graph, you can see the accuracy curve. Key observations. We have 89% accuracy of training, up to 87% accuracy on validation, up to 30% loss gap, and up to 80% optimal number of epochs. Here you can see the lesson classification accuracy and feature visualization, namely confusion matrix left and T-SNE feature visualization to the right. Clustering by lesson classes confirms the effectiveness of cross-attention fusions. And here to the right, we have the following metrics of approaches from macro F1 to MAE. Okay. Here we have medical triage and modality contributions. Triage categories and accuracy you can see here. So it divided from red to green, passing yellow, and when red, it's 95% is a critical conditions, stably classified regardless on sin conditions. Yellow, it's a serious condition. Care can be delayed. And green, it's a minor injuries, care is postponed. And here to the right graph, bar chart, you can see the modality contribution to prediction here. And conclusion on modalities. So visual data dominate, but the integrated plus 6 to 17 macro of AWAN improvement over single modality approaches confirm the value of cross-attention fusion. So you can see it here. Also, scientific novelty and practical significance of such research. Concerning the novelty, so it's a quality-aware feature fusion, unified cross-attention architecture, nonlinear risk function, disaster-specific preprocessing, and practical significance divided by rescue service systems, disaster medicine, military operation, VR or AR simulators. Also, here we have some conclusions and prospects. So the quality aware ReID, so identification approach reaches by now, it's 81%. Multimodal lesions ID, condition assessment and triage, it's 0.87. And the prospects, so lightweight transformer variants for edge devices, collection of real multimodal emergency datasets, and extension to video-based multimodal analytics, and the final, say, artificial intelligence ethics and explainable triage. So thank you for your attention. Also, if you have some questions, so please, I'm ready to answer them.
Yuri, thank you very much for your brilliant presentation. I would like to ask you a question. how does your system ensure reliable identification in the extreme environments, especially in the extreme environments?
Yes, exactly. So this work is mainly directed to extreme environment. So what could be these types of this environments? It's situations after, for example, some earth disasters. The first one, so some earthquakes, tornadoes, and so on. And the emergency services need to know how to proceed on the first stage, on the second stage. So who should be rescued from firstly, secondly, and thirdly, and so on. And also all emergency services within this system will have some optimization. So, and no need to some, for example, it not prevent to the time delays and so on.
Thank you for your answer. Any more question, please?
Thanks a lot.
Maybe some attenders would like to ask a question. So, is there no any more questions? Thank you very much again for your presentation, for the answers, for the question. And I would like to introduce the next presenter, the next keynote speaker. It will be Dr. Lixin. As I see, Lixin is with us. And it will be a presentation titled Multi-Objective Robust Optimization for the Multimodal Transport for Cold Chain Container under Uncertainty.
Okay, can you hear my screen?
Yes, now we may see your screen. You may, everything is good. You may start the presentation.
Okay. Okay, good morning, respected professors and teachers. Thank you, the ICAILE 2026 committee and Professor Kathy Zhang for your kind invitation. My name is Li Xin from Wuhan University of Technology. Today, my presentation focuses on the multi-object robust optimization of cold chain container multimodal transport under uncertain conditions. Now I'd like to start my report. My presentation will be divided into 6 parts as follows, which include background, research contents, model construction, experiments and results, sensitivity analysis, as well as conclusion and the future work. Now let's move to the research background from 3 perspectives. Firstly, the cold chain logistics market is expanding rapidly with its projected to reach 556.71 billion yuan by 2025. Secondly, strong regional transportation demand is evidence as the total freight value increased significantly from 2021 to 2025. Finally, the cold chain multimodal transport has emerged as a key trend, but decision-making in this field front with the multi-object conflicts and the numerous uncertainties. I think this is the challenges context for our research. So I collect relative papers from the 2016 to 2025 with a keyword of the cold chain multimodal transport, which includes 253 English articles from Web of Science and 237 Chinese core papers from CNKI. As you can see, the two charts, research on container cold chain multimodal transport are insufficient at home and abroad. So I think now we research is relatively limited, and therefore on the industrial side, practical optimization approaches are in urgent need. Meanwhile, existing academic studies are inadequate, which makes our research necessary to fill the research gap. Based on above the practical and academic need, I clarified the research objects and context here. Overall, this study constructs multi-objects modes for the three uncertain factors and develops the algorithm. My research falls into these three scenarios, which include uncertain carbon prices, uncertain demand, and uncertain transit time. And now let's look at our overall research framework. Starting from the uncertain carbon, and today we'll start from the uncertain carbon price. We set three optimization objects, which include cost, transport time, and satisfaction. We adopted DRO to quantify uncertainty, then use the improve HHO to solve the multi-objective problem. After that, we compare our algorithm with 5 classic algorithm, and finally conduct sensitivity analysis for carbon price changes. Now I built our multi-objective mathematical mode with 3 optimization goals. The first is to minimize the total cost. The total cost consists of these 5 parts. The first one is the transportation cost. The second one is the transshipment cost, and the second one is the refrigeration cost, and the cargo damage cost, and the carbon training cost. The detail the detail of the formulas are listed as follows. Among them, the robust carbon-free price is our research focus. Let me elaborate on it briefly. We adopted the DRO to depict uncertain carbon price. First, we set the constraints on the expectation, varies and value the range of the carbon price. And we finally simplify the robust carbon price into the concise formula. In short, robust price equal mean mean price plus and the fluctuation term controlled by the robust gamma. And the second target is the minimize the total transportation time. And the last one is to the minimize the customer satisfaction. And finally, we standardize these 3 objects into a single formula with the well-thin coefficients. And the detailed mathematical formulas are presented as follows. Then we set the 6 groups of the constraints. They include the single transport mode limit, transshipment limit, a flow balance, invalid path execution, and transshipment transshipment logic restriction, code commodity self-life constraint, and the variable and the B and negative rules. Next is our pattern matter setting with around almost 41 pattern meters in total. This covered network sets, fixed cost time, coefficients, co-chain indicators, uncertain carbon price settings, and decision varies for the subsequent numerical calculation. And the next one is the experiment. We set these three typical cold chain cargoes for a case today. The first one is the lychee from Haikou to Harbin, and the second one is the potatoes from Kunming to Beijing, and the frozen beef from the Urumqi to Shanghai. All products are packaged in 20 foot containers with the total value of the 20 TEU. The left paragraph shows the 30 selected multimodal transport cities across China, and while the right map marks the delivery routes of each commodity. And next, I will present the refrigeration parameters, unit cost, transit time for about the rail, the highway, railway, and waterway, carbons, and the carbon setting, and the commodity features and the relative data. And with all case data ready, we next introduce the calculation flow of our improved multi-objective Harris-Hawkins optimization algorithm. We first put the parameters and build the DRO model, then initialize the algorithm population. During the iteration, we adopted the leverage and differential operators to update the individuals, fix the invisible solutions, recalculate these objects, and update the achieved by the non-dominated sorting. Finally, we output the Pareto solutions once iterations finished. And I will take the lychee shipping as an example. I conduct modeling and computation on the MATLAB 2024. We first obtained the optimum rules and the multimodal screens under the three separate objects. And here I stand for the one stand for the highway, 2 for the railway, and 3 for the waterway. Besides that, we compare the Pareto front of our improved IMO HHO against the origin MOHHO, MOGW, and MOSSA, NSGA3, and NSGA2. As shown above, that IMO HHO achieved better Pareto distribution in the convergence and diversity than other 5 classic multi-object algorithm. And from the 3 objects, the improved IMO IMO converges faster and achieve the superior optimization performance compared with other 5 algorithms. Next, this table listed 21 sets of the 21 sets of the Pareto optimisms on the different weight combinations of cost, transportation time, and total time and customer satisfaction, denote as the W1, W2, and W3 respectively. The 3 objects conflict with each other. Higher weight on that target always worsens the other 2. In practical logistics decision making, decision makers can flexible adjust this 3 weight coefficients according to the enterprise operational demands. Maybe we can first consider the cost control for the cost-sensitive firm. Shorten the transport time for fresh cargo with a short shelf life, or maximize deliverers' satisfaction to enhance client loyalty. And also the managers can adjust the weight flexible based on actual business need to select the suitable multi routes. And with the growth of the robust coefficient, the robust carbon trade price goes up, pushing the total cost higher. To cope with the carbon price, the screen shortens transit time and improve the customer satisfaction. Larger gamma strengthens resistance against the carbon price flexion at the cost of a higher expense. Carbon training price exert remarkable impacts on the multimodal transport planning and play a positive role in the energy conservation and the emission reduction of the transportation industry. So in the future research, I think I will continue exploring the multimodal transport considering the uncertain demand and uncertain transit time, and introduce a green policy and the carbon tax into the DRO optimization mode to analyze the policy impacts on the route selection, and to extend the mode to the multi-consignment, multi-origin destination, practical cold chain logistics, and verified modal practicability with more real industrial data. So, okay, that's all my presentation. Welcome your questions and discussions. Thank you very much.
Thank you very much for your presentation. And now, questions, please.
Oh, well, thank you for sharing. I have one question. What are the differences in optimization between cold chain container multimodal transportation and general container multimodal transportation?
Okay. Okay. For your question, I think compared with the ordinary container multimodal transport, I think the cold chain shipping need extra refrigeration costs and temperature control constraints. Besides, the fresh cargo has straight self-life limited, and making delivery time critical optimization objects. Meanwhile, cold chain involves more uncertain factors like temperature and the carbon expense. So we adopt a robust optimization to handle these risks. While the regular container optimization mainly focus on the cost or the transit route only.
Oh, thank you. Thank you for your answer.
Thank you. Any more questions, please?
May I ask a question here?
Yes.
Okay, thank you for your amazing presentation, Professor Lee. I have two questions. The first one is, are there conflicts among the optimization objectives of cold chain multimodal transportation, and how to balance these objectives? And the second question is, your future research will focus on uncertain demand and transshipment time. What other uncertain factors can be further explored? And why is the uncertainty of freight rates not considered in this study? Thank you.
Okay, good question. Thank you for your question. And so for the first question, I think obviously conflicts exist amongst the cost and transit time and customer satisfaction. So I think cutting logistics cost usually means choosing slower transport modes, which so the delivery time and reduce cargo freshness and satisfaction, shorten the transit, always rise the transportation expenditure. So we balance them into two ways. The first, obtain a set of the Pareto non-dominated solutions while the improve multi-objects algorithm. Second, adjust the weight of this target according to the actual business demands to pick the most suitable and practical part. And for your second question, I think other promising uncertain factors include carbon price fluctuations, road or the road detention duration and cargo loss rate, all common in cold chain logistics. And the freight rate uncertain is not include mailing for research, simplification and the boundary definition. And this paper certains on carbon price and the transit and transshipment related uncertainties for the distribution natively robust modeling. We will encompass the freight rate into the mode in the follow-up research. So maybe in the future we will focus on the others uncertainties. Thank you for your question.
Thank you for your answer.
Thank you, Professor Lee. Thank you, Professor Lee. Your answers are very impressive. Thank you.
Thank you.
Thank you again. Any more questions, please?
Okay.
As I see, there are no any questions. So thank you very much for your presentation and for the answer as well. And now we have to switch to the last one presentation from the keynote speeches. This presentation will be performed by Irina Dovbyshchuk. As I see, Irina is with us. Good morning. And this presentation titled AI Relevant Data for Supply Chain Resilience under the Full-Scale War. So please, you may start your presentation. You have about 30 minutes to present all your scientific results.
Welcome, Irina.
Thank you so much. I'm just trying first show you a little bit of my slides. Give me a second. And then I will start immediately. You have somehow very sophisticated settings here. Typically, I don't have so many conditions to share my screen. I need to click through. Now I need to recall all my passwords. I hope I will be good in this. Give me a second. My administrator password, I use it only in seldom occasions. So you will be able to see part of my screen in a second. I'm just framing the part I'm going to show you.
Now everything is good.
You
You
can
may
see
start.
the screen,
Yes.
the
Yes, yes,
slide,
yes, we
right?
can see.
Okay.
Yes.
So
yes,
my name
yes.
is Irina in English, or Ilina in Chinese, or Irina in Ukrainian. I am Ukrainian native, German, residing in Canada, Calgary. I'm associate professor of international business and supply chain management. And I am recently very interdisciplinary in what I do in terms of supply chain management. And the title of my today's presentation is about resiliency and very high uncertainty. So I will continue uncertainty theme from Professor Lee in the previous presentation, but the level of my uncertainty in the presentation is much more higher. Because the duration of uncertainty and the intensity of uncertainty is at a different level, but still it's the same topic. What we can do with uncertainty in supply chains using technologies, and one of them we have in our daily life is artificial intelligence. So the topic is how we can deploy artificial intelligence to improve resiliency if uncertainty is lasting and very intensive. And with combination of uncertainty, so it takes a lot longer than just one container freight movement from A to B. And the intense of disruptions and overlapping of disruptions is a little bit different, is very good visible if we have conflicts like full-scale war level, bunch of disruptions pushing on businesses if they are affected, situated inside of their area where war is happening. That is like their practicable imagination of this kind of uncertainty. I will use in my presentation using insights from executives in Ukraine. Their full-scale war is happening since a very long time. So what does this mean for supply chain management before we dive into AI and some ideas I have how AI can help to keep an eye adaptation and recovery during with a high level of uncertainty. So now you should be able to see my second slide with motivation for today's keynote. And motivation is threefold. So the first bullet point you see is about supply chain resiliency research we have at the moment in supply chain management field. So we know a lot of our understanding has advanced of how firms prepare or respond or recover from disruption. But we still, in supply chain management, we treat disruption as a bounded event. So it's a short-term event. And we treat it like something we need just recover from. So that is my first bullet point. So most of research we have is about recovery, engineering-based resiliency. And this type of knowledge is valuable, but it has no value if we have full-scale war. So it has no value if we have continuous, long-lasting disruption and high levels of uncertainty. So that's why I took Ukraine, because Ukraine is it's sadly that war is so long there, but it's an opportunity for researchers to have this case of such high level of disruption and uncertainty. So the war itself is like challenging with recovery centered view in supply chain management field, because most of research is about just recover and like gain your competitive advantage as soon as you can. So wartime disruption is not a short-time shock, but a sustained condition of destabilization affecting logistics networks, affecting governance routines, affecting entire environments of companies and supply chains, leadership structures, and institutional coordination across multiple system levels. So that is basically my second bullet point you see on the slides. And lastly, how can technologies help to overcome those very difficult, very demanding situations? So AI-enabled resilience is not only technical, it could be socio-technical. So not only technical. And the strengths of AI supply chain resilience could be align not only data, but we use AI to explore. So to deploy explorative learning from the data, because we don't know always in such difficult situation which data we need to do better decisions and to react very fastly. So that is some of like DAI publication is about like why not to concentrate on explorative learning as well, while organizational inertia weakens with effect. So it's very important how organizations deploy technology, like how we use AI relevant data. For wartime Ukraine, with shifts attention from AI as automation to AI relevant data, then can support sensing, can support learning, can support adaptive reorganization under extreme uncertainty. So that is the motivation of looking at this type of resiliency and how AI can help in my presentation. I will have two research questions. The first one is how to understand or how to see in the context of full-scale war, cross-scale adaptivity. So how to grasp that it's not only my business, it's not only my supply chain, it's the environment around. So how to connect what's happening in the environment to supply chain analytics and to business decisions, daily business decisions. So that is basically first question, and how to see how differently adaptation is at their supply chain level, at company level, and at political, economical level of a country. So it's kind of multi-level approach, how I see supply chain resiliency, to see what is happening in between scales, because it's not only company and it's not only supply chain, it's more if it's such a high, extreme uncertainty case. And lastly, the second question is about AI. So how can AI relevant data make with adaptive cycles visible and support managers, decision makers in sensing, in learning, and reorganization in wartime supply chain? What I have is a little bit like grounding on this slide in the literature. Once again, underlying what we know conventionally from supply chain research in terms of like most of studies are recovery oriented in terms of resiliency. And we often reflect with engineering resiliency logic. Disturbance is short, temporary deviation from business as usual, find the way to come back to business as usual. So it's like bouncing back recovery, and it doesn't work in wartime context. So with this type of resiliency, that is not helpful. So my study starts from the observation that recovery is not always the right language. Resiliency requires in wartime more than just recovery. And in Ukraine's wartime context, supply chains are not simply disrupted and then restored, where you're disrupted, and it's like since years where you're disrupted. So it's like different level of resiliency. And the basic conditions that normally make recovery possible, we know from literature, like infrastructure, territorial control, enforceable contracts, reliable insurance conditions, and predictable regulation are themselves unstable. So everything is unstable, and that is this extreme uncertainty. This is why I move from recovery centered view of resiliency to an adaptive system view of resiliency. In order to have this kind of complicated view, I use Holling, who has proposed engineering resiliency, but Holling was also the one who proposed to look at systems in around us in economy, as well as socio-ecological systems, so that we see resiliency as adaptation-oriented resiliency and not recovery-oriented resiliency, because recovery is not that possible in such short time. That is why I will show you a little bit Holding theory, and that is the one that was recently rediscovered in supply chain management, especially by Wieland, studies around Wieland and Adobo. So we started to say, like, hey, it's not enough to just look at resiliency from recovery perspective. And the next slide is a little bit heavy to understand, probably, if you see this theory for the first time. That is the panicky theory. So panicky gives me in the study kind of vocabulary to trace what happens. Then disruption unfolds across different levels. So you have here supply chain level, that is small and fast level. The next level is political economic level, that is intermediate size and speed level, and the highest level is the planetary level. So if you deal with such extreme uncertainty, decisions made in China, decisions made by Trump, they also matter for the entire cross-scale dynamics. And the core message is that this theory helps explain how release and reorganization unfolds across those three levels, because each level is from nature, is adaptive, and is viewed as a cycle. So each level goes through specific phases, similar in nature, and the system moves through exploitation, then to conservation, and finally release and reorganization. So I tried to track those conditions we know from adaptive cycle in the panicky theory in this very extreme uncertainty case in Ukraine. And basically, I was mostly interested in supply chain level and decisions of managers, what we do with supply chains, how we react, like which difficulties they face, what they have learned during so many years of war, and war for them is business as usual. And the first research question is about cross-scale coupling. So do we see any effects between scales, like how political economic level can slow down or reinforce, or vice versa supply chain, what businesses do, how businesses solve with difficult situation, which consequences it might have for a higher level that is actually slower. So that is like you see a forest and you see trees. So I am interested in one tree, but I keep an eye on the entire forest to see the cross-scale dynamic. Okay, so I go to the next slide, and that is methodology. So what they did, like how to get data about this, right? So easy, like fieldwork in Ukraine is very difficult at the moment. I would love to see my family, but I understand, like, for my university, it would be very difficult to explain, and it's like impossible at the moment for me to do field work. And since I'm in Canada, the time zone difference was so big that I was thinking to connect online, but it's really challenging at the moment. So I tried to figure out how can I get data from decision makers. Nevertheless, I cannot travel and I cannot connect digitally. And I was happy to find, so I was just trying to figure out what could be good source. And I found some studies in supply chain management proposing to use secondary data we have through social media. So that social media is actually very intensively growing. And of course, quality of social media is different. And I tried to keep this in mind because I found this idea very creative. So why and how we can use social media to have more data about decision making. And I was blessed to find a podcast, publicly available podcast of CEO Club Ukraine, which is a podcast they do on a regular basis panels with executives, with public actors, with political authorities, decision makers. And we have different topics, but we are inside of the country where war is happening. So almost in each panel, their cross-scale or adaptivity or recovery or resiliency of war as a condition of doing business was touched. So I spent a while listening to those podcasts, and I took the entire year, so like from January 2025 till February 2026. I found 13 podcasts out of I think more than 27 podcasts, very helpful because they were very closely related to what I was interested. So how managers adapt what we do, how we see, and same about the political economic cycle. So I selected some of them. I still can speak Ukrainian, so for me there was no language barrier to transcribe and understand what we say and how we say, like to the cultural nuances of what they say. And that is how I came up with a lot of data, questions and answers of executives, because CEO is for CEOs, so it's senior executive level. And I spent a while listening to this, and methodologically the study is designed to be a longitudinal embedded single case study, because like panels were like spread it within the year. So we were all made during Ukraine under full-scale war, and I treated this like extreme case, listening to those panel discussions, because of disruption was not episodic. In each panel, disruption was still there. And it is sustained because it's multi-level and politically embedded, which makes easier to see like cross-scale effects between supply chain and political or adaptive cycles at different levels. And my purpose was not to measure resiliency statistically, because I'm working with qualitative data in comparison to Professor Lee before. But I tried to trace theoretically specified processes in the panicky theory, like moments of release of their existing supply chain structures, routines, or governance mechanisms, or moments breakdown, or moments of reorganization mentioned by executives where actors recombined resources and developed new coordination arrangements because of extreme uncertainty, and cross-scale coupling. So how we depend on what regulators do, how we depend if laws specifically what changed their operational adaptation interacts with their political economic governance. So empirically, I draw on 13 CEO podcasts. These episodes include 26 seniors. So I had 26 opinions from different area of decision-making, like policy actors, executives, institutional representatives from economically significant Ukrainian and international global buyers, so multinational enterprises. And I spent around 25 hours of material to screen and transcribe and finally analyze. So how I did analysis, so my analytical strategy was that I was theory driven. So I saw panicky as like vocabulary in my like screening the data. So it was not inductive in a poorly ended sense, because panicky theory directed my attention to prolonged disturbance or to multi-domain destabilization we were talking about, or cross-scale feedback I could see through panicky vocabulary. So I coded material for 3 types of evidence, like what I see in the evidence about release, where existing supply chain structures or routines broke down, what I see about reorganization, where actors recombined resources and developed new coordination arrangements, and which coupling mechanisms, because panicky has very classically with 2 coupling mechanisms where you remember and revolt. So I was trying to see empirically, would it be visible in such extreme case where adaptation is so like required? And that was something new. So there are no studies about this in supply chain management, because it's very difficult to find like data and like such a severe case to see this so like obviously. That's why I was so motivated. Will I see it or will I not see it? So this executive accounts were triangulated them. So I did triangulation with policy documents. Each opinion I tried to recheck with broader evidence, both in academic literature and gray literature, like institutional reports, sectoral indicators, and relevant supply chain management in international business literature. And at the same time, I treated public elite discourse critically, acknowledging visibility and survivorship bias as part of interpretation. Okay, so I don't have time to show you like the sample. Let us just dive into findings. So what I saw in findings analyzing was records. So the first finding is about asynchrony. What I saw in which type of like opinions are generally like aggregated for. At the supply chain level, release was immediate and visible. Assets became inaccessible, logistics corridors collapsed, depots and infrastructure were attacked, and firms had to continuously remove or remodel continuity. So there was no continuity anymore because of full-scale war. And with rapid operational release, I saw did not occur alongside equally rapid political economic transformation. So what I see a huge discrepancy, what is happening in supply chain level, so how businesses are fast adapting to this and how slow is political economic level transformation on it. So like state procedures, regulatory routines, and broader geopolitical institutions adapted more slowly than supply chain level. And this means that wartime resilience is not a movement back to stability. It is adaptation inside a prolonged release environment. So I see like entire year of conversation was about survival, was about continuous like adaptation mode. It was not about recovery. So what you see here, basically some lessons learned. So if you see like 199 or like some numbers, that is like how I transcribed interviews, so that I saw a lot of similarities in opinions between different CEOs and different industries, because we all are operating under full-scale war in Ukraine. The next what I saw, or what I was interested in, is to see a kind of reorganization, because Panicky says that after, like, because of continuous adaptation, reorganization is the next phase in the adaptive cycle. So this slide shows one of the core findings. Under full-scale war, reorganization does not begin after disruption ends. It begins while disruption is still unfolding. So it's like overlapping conditions, typically very typical for adaptive cycle in the Panicky theory. So the first pattern is immediate strategic reorientation. I saw executives do not describe adaptation as a normal recovery process. So this resiliency, as usual in supply chain management, is not something they do. It's like, it's not explainable with this piece of knowledge we know from supply chain management. So we frame it as a survival imperative. So I one of the quotes, like very like transferring this, is either we transform or we die. So that is the attitude of executives that was like visible in conversations, captures with very directly, I think. In Panicky terms, the system is still like in release, but firms are already entering reorganization. And this is also visible in scenario planning, for example. And I was 4 weeks in Helsinki for the international conference, IPSARA, about supply management. And there was only one study from a colleague from Ukraine. She was co-author from Kyiv National Economics University, named after Hetman. She has presented with a very strong editor of a ranked journal, a publication. I think it will be published. They collected data online from executives in Ukraine, and they came up with exactly the same lessons learned. And the lessons learned is scenario planning. So that Ukrainian executives, they begin to rehearse not only difficult scenarios being in a very difficult situation. They just learn to do scenarios for unimaginable things, and they do it not only at business level, they do it at supply chain level. So planning becomes less about forecasting, like we teach students, right, to forecast, use data from the past. They don't have stable futures, so they do more about preparing for multiple forcible breakdowns. And it's amazingly that in the study I heard like 4 weeks ago, to totally different methodology. It was also visible for me in this conversations, because how we do, like we called the bank. I remember one said, we called the bank and we asked, hey, today we trained this scenario. If this will collapse and this is not many, like this is not many walkable, what will you do? Like, we need to know in this scenario what to do. Like, you as a bank, we need you, right, in our operations, but are you prepared for this scenario? And this kind of preparation is a new routine. Like, it's a new business as usual because of this continuous learning and adaptation. And this is the first pattern I saw. The second pattern is resource and logistics recombination. So I saw firms are not simply restoring their pre-war supply chain. So it's not about restoring recovery of warehouses or terminals. They are rebuilding them with different resources and different labor pools and different routes. So it's a kind of, for example, workforce shortages, especially male workforce shortages, or because of immigration, refugees flows from Ukraine. They push companies to include people who were previously outside the labor market. They push companies like older workers, for example. At the same time, the collapse of like the pre-war Black Sea logistics architectures forces companies to reorient exports toward Europe. So they do like strategic shift in, like, if this logistically destination is not available, I change my exports flows, like to whom I sell, not where, like logistically I do this. So that I saw intentions to do exports towards Europe and America. So like this is not just rerouting logistically, like in technical sense. It requires new corridor arrangements, new cross-border coordination, and substitution through railroad to Danube routes. Even then, these alternatives create regulatory and infrastructure bottlenecks. So this is the second pattern I saw. And lastly, the third pattern is that adaptation becomes distributed across partners. So reorganization is not only contained inside the firm. Firm involves suppliers, logistics partners, export networks in preparedness. So the quote, we simulate extreme scenarios and then call our partners, is not only calling banks, it was repeatedly said by different executives that it's their business as usual now. So what we can, like in terms of finding, what we can learn about supply chain reorganization, consolidating wartime adaptation. So we need to, like, this slide moves from the first signs of reorganization to its consolidation. The main point is that wartime adaptation becomes more durable than it is built into leadership structures, workforce arrangements, coordination routines, and operating models. First, leadership authority becomes more decentralized and trust-based. That is what I saw. And under full-scale war, centralized systems are often too slow, too rigid, too vulnerable to disruption. So firms reported that they redistribute decision-making across organizational layers. That is not simply chaos or spontaneous improvisation what they do. We said decentralization works only when it is supported by constant communication, and that is like data, like real-time data is necessary here. Trust, of course, trust was fundamentally important, CEO said, and it shows that wartime resilience depends not only on formal authority, but on whether people are trusted to act when centralized control is no longer sufficient. Second, firm recombine organizational resources. They do not simply try to restore the workforce. They do not restore management structures they had before the invasion. Instead, we redesign them under conditions of labor scarcity, of mobilization of people, male especially, migration and financial pressures. So some firms reduce staff and redesign the business model, like strategic adjustment. Others, they try to retain key workers through draft reservation. Others replace top management or build redundancy into leadership roles. And I like the phrase, every top manager must have a number two just to survive and be on time, like fast exchanging and adapting. So it means that resilience becomes organizationally embedded through backup roles, succession capacity, and distributed managerial responsibility. And third, relational coordination becomes a substitute for weakened formal institutions. Where formal insurance or state protection or institutional safeguards are limited, firms rely more heavily on trusted business networks, partner relationships, and diaspora ties worldwide, which does not mean that formal institutions disappear in such a context. Rather, it means that under wartime uncertainty, trusted relationships become more practical as coordination mechanism. And finally, operating models become resiliency oriented. Firms are not only surviving, we are changing how we operate. Technological adaptation is one of adaptations. I heard a lot. Automation, platform improvisation, and new sectoral opportunities become part of reorganization, like part of business as usual. So you see on the slide the global quote, with the war we kept growing, but it became resilient growth. Captures the shift very well. So we keep somehow growing, although we understand resiliency, like adaptation is new business as usual. So it becomes growth that's constrained by uncertainty, focused on continuity, and shaped by the need to remain operational under disruption. So what I see like for AI in this lessons learned about extreme uncertainty, so how we can use AI relevant data to do adaptive cycles visible in such extreme situations. So with Stable is my intention to translate the empirical findings into an AI relevant data perspective. The point is not that AI replaces managerial judgment in wartime supply chains. The point is rather than AI can help organizations notice patterns that are otherwise fragmented, delayed, or invisible while the crisis is still unfolding. So the first row here focuses on release, where the system is breaking down. So damaged infrastructure, blocked corridors, delivery failures, workforce shortages, institutional bottlenecks are not only operational problems, they are also like data traces. If captured systematically, using AI, they can support early warning and disruption sensing for supply chain manager. The second row is more about like how to focus on the beginning of reorganization, deploying AI technology. Here we can look at how firms start to respond, like rerouting, emergency procurement, export market shifts, assessments, scenario simulations, and partner responses performance. These traces can help organizations learn from emerging adaptations under or rather than treating each response as isolated improvisation. And finally, the third row asks whether adaptation is becoming more durable. So delegated authority, backup, leadership roles, or trusted coordination networks, automation, uptake, and new operating models show where reorganization in a supply chain, in a company, is consolidating. And this is where AI may support decision-making too. So it's not only just by predicting risks, but by helping firms recognize which adaptations are becoming stable enough to guide future action. So the key message is that AI-relevant data can make adaptive cycles indeed visible. It can help us see where release is happening, how reorganization begins, and whether wartime adaptation is consolidating into new supply chain capabilities. So what are my conclusions? The first conclusion is that under full-scale war, resilience is not a return to normal. In the Ukrainian case, firms, they do not have they do not move neatly, fastly from disruption to recovery. and release and reorganization as phases of an adaptive cycle. They overlap greatly. Supply chains are breaking down and being rebuilt at the same time. And this means that resiliency theory needs to move beyond the recovery logic to pay more attention to adaptation inside disruption. The second conclusion is that this adaptation is cross-scale. So operational decisions, this is only one level, such as like rerouting or workforce restructuring or partner coordination. Nevertheless, they are shaped by the forest, if it's a tree. So they are shaped by slower political, institutional, security, and infrastructure conditions. Firms may adapt quickly, but they do not do so inside a wider political economic cycle that changes much more slowly. And this is why panicky as a theory was so useful to look into this dynamic under such extreme uncertainty. It helps us understand resiliency as interaction across system levels, not only as firm level capability. And the third conclusion is that reorganization becomes durable when it is built into new structures. In the findings, this includes recombining resources, decentralizing leadership authority, or creating backup roles, relying on trusted networks, and like many examples, how which instruments might be deployed. And so resilience is not only about surviving the shock, it's more about whether these adaptations become stable enough to support continued operation under continuous uncertainty. And this is where AI, relevant data argument becomes so important. AI can help make these adaptive cycles visible while they are still unfolding. It can support sensing by detecting where release pressures are intensifying. It can support explorative learning by linking firm-level signals with logistics, institutional, geopolitical, and infrastructure data. And it can support reorganization by tracing whether new routes, partner regiments, leadership structures, and operating models are becoming more durable. So the final message is that wartime supply chain resiliency is cross-scale adaptive reorganization under sustained destabilization. And AI is relevant, not because it removes uncertainty, it doesn't, but because it may help organizations see, learn from, and respond to adaptive change while they are still inside the crisis. And that is my last sentence, and I am happy to enjoy some questions or remarks from the audience. And I am very sorry to join you shortly before my slot, because I teach in Hanoi at the moment, and I have indeed lectures on Saturday. So I interrupted my lecture to join you distributed on this planet. Thank you for your attention.
Thank you very much for your brilliant presentation. And now, question, please. As I see, we have a question. You may ask a question, please.
Han
Yes,
has a question.
thank you.
Hello,
Thank
Han.
you for your amazing presentation, Professor
Han.
Irina.
Thank you.
As you said that the firms need to combine resources and logistic structures, right? And you mentioned the recognition materialized through workforce and the supply chain restructuring. So my question is, what is the relationship between workforce and the supply chain resilience, especially based on the AI data, the background? Thank you.
So if you think practically about situations where you have warehouse operations, for example, and because of mobilization of male workers, yesterday you had 10 workers, today you have 5. So if you deploy AI already in your warehouse operations, perhaps your automation levels will allow you to adapt to this shift in available workers till you find probably replacements for them. But at the same time, AI can help you to assume probability of situation tomorrow that 5 out of 10 workers will be mobilized, because you can collect some attributes saying you that very possibly you can face with situation in terms of your workers. And at the same time, it's operational level workforce, right? I heard many voices from executives that people burn out. So that people are responsible to do with permanent decision making, like you have one fire and you have simultaneously 2 more fires, and you need to have a plan how to react. I think AI can simplify decision making even for executive level at a higher level, so that we are not burned out so fastly, and that we can do better data-driven decisions, preventing company looking for their replacement, not because of mobilization, because of mentally difficulty to handle with very difficulty level day by day. So that is the executive level workforce. And I think AI is also very helpful in such situations, just to have kind of cockpits aligned to wartime disruptions around you, so that you have cockpits of data, like kind of dashboard, real-time dashboard, combining different pieces of information in terms of threats and scenarios, how you can respond. I heard a lot of voices from agriculture, for example, so that in agriculture we have lost fields because of war. They have lost like half of areas where they have wheat or where they have rapeseed oil, and how we survive, they use more drones. They are faster, so they replace employees with drones, and they were very good in drones applications before war started, but the war forced them to be even better. And they are like, if you use drones, you cannot do it without data, right? You need geographical data, you need weather data, you need a lot of data. You do your daily operations, and at the same time, that helps you to replace workforce. And that is just 3 examples, but still, all of them are so specific in terms of data you need, but you cannot be better without. So it's always about data and availability of data on time, so that it's really real time, helping to do better decisions in such difficult, disruptive environment. I hope my examples helped you to grasp the complexity.
Yeah, very impressive answers. Thank you, Arina.
Thank you, Han. Thank you for your question. Do we have more questions?
Yes, I see we have one more question, please. You may answer.
Katie, hello.
Yes, thank you, Arina. Your research content is very rich. I appreciate your speech, but the time constraint not allowed us to discuss furthermore here. So I hope we can cooperate to study supply chain, especially AI empowered supply chain. Maybe we can have some cooperation research. Your school and my school. Okay.
Yeah, why
maybe
not?
we can discuss. Okay, later.
Thank you so much.
Nice to meet
Thank you,
today.
Katie. Thank you. Thank you for having me.
Thank
Thank
you.
you.
Thank you.
Thank you.
Thank you.
Any more question, please? Oh, in this case, Irina, thank you very much for your presentation again, for the answers.
You're welcome. Thank you.
And now we finish with first part with keynote speeches. All keynote speakers finish their presentation. Now it's time to switch to the ordinance section. We have, according to our scheduling, the several presentation for the first part until the break time. So I would like to invite the first presenter from the ordinary section, paper number 33, 52. 33, 52. Is presenter here? This is a paper.
Yes, yes, yes,
Yes.
yes.
So
Okay,
you
so
have
shall I start?
you may start, but several words about the time limits. Due to our
Okay.
schedule, we have about no more than 10 minutes for your presentation and for the answer question answer section as well. So please take into your mind the time limit, and you may start your presentation, please.
Okay, so I will share my PowerPoint. So it can be seen
Yes.
the PowerPoint.
We see your
Okay.
presentation. You may start. Please begin.
Okay. Good afternoon, everyone. Okay, my topic is about the physical content breach and the over-intention under the AI algorithmic management. So today I will from the 5 part to start my presentation. For the first one, we think due to the current slowdown in economic development and the impact of the AI, college graduates encounter a lot employment challenges such as the job instability, career mismatch, and the difficulty in job searching. And we can say nowadays the food delivery services have become very common. And as the transitional stage, many college graduates choose to take up the job of a delivery man. So how to effectively promote the high quality for employment of the college graduates has become an important issue in the field of the employment study. Specifically, what are the key factors influencing the college graduates' career choice is our issues we want to do. So and then after we read some the literatures and we say under combined influence of the high distract, no emotionally commitment and extremely low the no switching cost. The physical contact breach will lead to the over-intention, and the income gains from the AI trust will reduce the college graduates to over-intention. And the other one is when online labor platforms imply the great income security mechanisms and establish the equitable performance evaluation rules and the feedback channels, college graduates may maintain the employment stability. And then, according to this, we'll provide our hypothesis, which is which are 2 or 3 hypotheses. And then we do our research design for our data and the samples. Actually, with a total of 242 college graduates with a flexible employment experience were recruited for this study. And according to the questionnaire-based survey, as administered to all the participants. Finally, we received the we received 225 to 40 valid questionnaires were returned for this analysis. And we show the table 1 is the demographic information about all the participants. And then for the questionnaire design, all the skills we employed in the study were systematically adapted from the established international skills, and it is suitable for our research. And all the constructs were evaluated using a 7-point Likert score and analyzed with multiple indicator in items. And we choose independent variable and mediating variables and dependent variables. For the independent variables, the physical contact breach was measured by 7 items. For example, the item is the
the platform provides the compensation matching with my contribution. And the other, like the institutional trust, was measured by the 8 items. The example of the item like AI technology is reliable. And the dependent variable, the turnover intention was measured by 3 items, which the example can be say is I will quit from this job immediately when I find the other suitable means of the making of a living. So according to our research design, we obtain some data and we do the data analysis for the reliability and the validity test. We do some test and the data shows the Cronbach alpha of all variables range from the 1.8 and to this is pretty high, and the CR values of all variables range from 0.8 to 0.9. The reliability and the validity of the skills passed the test. And then we do the test of the direct and the mediating effects, which can be seen the figure 1 and the table 3. We show the past analysis of the effect. According to the result, this is sufficient evidence to support our hypothesis 1 and the hypothesis 2 of this study. While this is no evidence to support the hypothesis 3. So this is our result. According to our results of our study, and we do make up some implications. For example, the first, optimizing the policy guarantee mechanisms to achieve the high quality for employment is usable. And the second, actively guiding and promoting the online labor platforms engage the transparency of the AI algorithms is also very important. Finally, constructing the feedback and internal channel for the negotiation with the platforms and the employees or the gig works is also very important for the graduate students to find the different jobs and to do the career development channels. So according to this, both of the us is our presentation. Thanks for your listening.
Thank you very much for your presentation. And any question? Any question, please?
Yes. Maybe the questioner cannot get out in the meeting, so maybe I can answer one question about some meetings. As we mentioned before, due to the current slowdown in the economic development and the impact of the AI, college graduates encounter a lot of the employment challenges, and they try to take up the job of a delivery man to make a living. But how they can obtain an order online always decided by the platform AI management. So we are interested about this topic, and under the AI management, what factors may influence their turnover intention? It's quite interesting, and maybe our research can help the Chinese student, the college students find better career development paths. So we do this research, and we can say that another questions about this topic.
Any more question, please? Okay, if there are no any new question, thank you very much for your presentation. And now we switch to another presentation, next paper. Next paper is number 3379, factor analysis of AI-driven education demand in Chinese higher vocational college. Is presenter here of this paper? paper, next paper. Again, factor analysis of IE-driven educational demand in Chinese.
Hello, President. Hello, President.
Oh, yes,
3379.
Yes, 3379, please start your presentation. You have 10 minutes about to perform your presentation.
Thank you, President. Thank you. Okay, so good afternoon, distinguished guests. Today, I'm honored to present my research on AI-driven educational digitization in Chinese higher vocational colleges. As we know, artificial intelligence has emerged as the core edge of fourth industry revolution. In the education sector, AI is driving a transformative shift toward digitalization. The application of digital technologies to revolutionize teaching and learning. So the part one is about introduction. One, tracking AI investment in Chinese vocational colleges from 2023 to 2026. This paper explores the tangible outcomes of China's AI Plus and educational digitalization strategies by examining the correlation between national policy directives and actually institutional spending. It highlights the rapid increase in procurement budgets within higher vocational colleges. And two is affect alliances of AI-driven educational digitalization. Despite a surge in financial support, the specific structural allocation of resources remains under-researched. This paper utilized the factor analysis to bridge that gap, investigating whether the doubling of funding aligns with the actual release of AI integration. And three is alliances of publicly tendered projects in higher vocational education. Focusing on the evidence and the data, this research analyzed procurement data from publicly tendered projects spanning 12 quarters. The paper maps the trajectory of digital shift in vocational education, offering data-driven insights into the challenges and opportunities facing the sector during this AI-driven transformation. And part two is about my research methods. Based on the factor analysis method, this paper selects all categories and items, including both central and local announcements from the China government's incumbent website for the period from 2023 to 2026, using the keyword higher vocational colleges to search and collect data, spanning a total of 12 quarters. 6 indicators were chosen based on the principles of scientific validity. So you can see from the table, AI employment and empowerment, and teacher training, that's the one. Professional integrating and curriculum development, that's the two. Digital teaching and resources, that's the three. And the platform and infrastructure, the four. Quality and evaluation, the five. Campus governance and public services, that's the six. Both the KMO value and the Bartlett's test passed the significance test. The KMO value is 0.613, which is greater than 0.6, meeting the prerequisites for factor analysis and indicating that the data are suitable for the research. Meanwhile, the data also passed the Batness sphericity test, suggesting that the research data are appropriate for factor analysis. After obtaining the coefficient matrix of component scores through SPSS, a factor scoring model can be derived. So, based on the high correlation loadings of the three indicators from the table, we can say that D1 and D2 and D5, we extract factor 1, the teaching reform and the quality enhancement factor, given that both D3 and D4 exceeds 0.4, we extract factor 3, the infrastructure development factor. And the factor 2 is the campus governance and service factor. So based on our analysis, we can have a conclusion. 1. Shifts in demand focus from hard infrastructure to software power and deep integration. And 2 is construction model exhibits dual peak characteristics featuring both large-scale infrastructure and high-frequency niche applications. And the last is technology preference, focusing on emerging technologies and the integration of physical and the virtual worlds. Okay, that's all for my presentation. Thank you all for your attention.
Thank you for your presentation. Any question, please, for the presenter? Yes, you might ask a question, please.
Okay, I want to ask, based on your factor analysis of the pre-assessment data, could you summarize the key shifts you observed in the digitalization demands of Chinese higher education colleges?
Thank you for the question. So our analysis of the tender data from 2023 to 2026 reveals a significant shift. The demand is clearly moving away from hard infrastructure, such as basic computer labs, towards software power and deep integration.
Okay, thank you. Thank you for your answer. And any more questions? In this case, we finish with your presentation. Thank you very much again. And next one presentation. Next one presentation is number 3449 presentation. I'd like to ask you to turn on your screen demonstration, turn off your screen demonstration, in order to give possibility for the next presenter to start. Okay, as I see the next presenter is with us, so you may start your presentation about 10 minutes for the scientific result.
Okay.
Yes, we see your presentation, everything is good.
Okay. Good afternoon, respected professors and peers. My name is Xinrui Liu from School of Transportation and Logistics Engineering, Wuhan University of Technology. Today, I'm going to present our research titled Intelligent Warehousing Inventory Optimization based on Demand Characteristics and K-means Clustering. This paper is completed under the guidance of Mengya Zhang, together with Yueran Wang and Kevin Xiong. Here is the presentation outlined. Now move to part 1, Introduction. Traditional inventory management has three flaws: subjective classification under fixed ABC rules, experience-based inaccurate replenishment, and poor real-time data sharing. Accordingly, we aim to build a data-driven inventory model to reduce unnecessary costs. Next, come to part 2, our core research methodology. We construct a 3-layer framework: demand perception, fan sales breakpoints, variety clustering, combined sales ranking, and k-means to build a 2-dimension classification model. Intelligent decision set differentiated inventory rules for automatic management. Our goal balances supply service and inventory costs. Here is our first classification method: objective sales. Popularity dimension with a natural break point, different from the fixed 80-20 ABC rules. We calculate actual sales distribution and find the critical turning point of cumulative outbound volume. As a dividing benchmark, splitting all SKUs into H, high sales, and L, low sales groups. Each item contributes most revenue and need priority inventory arrangement to avoid stock out. L, long-tail item take large product quantity, and strict inventory control prevents overstock. This data-based dividing rules can update dynamically following SKUs changes, makes all inventory choice fully data support instead of arbitrary human definition. Then our second method, k-means-based demand stability grading and 2-dimension classification model. Step 1, we calculate coefficient of variation of historical demand and use k-means clustering to automatically divide goods into X, stable, Y, medium fluctuation, and Z, volatile, 3 sets. Remove the defect of the artificial fixed threshold in traditional XYZ analysis. Step 2, process each L sales attribute and XYZ stability attribute, forming a multiplied 2x3 matrix with 6 product clusters: HX, HY, HZ, LX, LY, LZ, each with unique demand features. This multi-dimension grouping lays solid groundwork for differentiation inventory policies. We cite different service levels and replenishment rules for 6 categories to balance costs. Specific parameters can be seen in the table. Besides, the own set of rules can be embedded into existing WMS warehouse management systems to realize fully automatic parameter adjustment and real-time replenishment trigger. Now, part 3, case study. We select F fabric store, a typical medium-sized multi-SKU textile warehouse, as our verification object. We adopt its full year 2025 outbound data set, totally 4,000 SKUs consisting of 80 fabric varieties and 50 color specification for each variety. Our test target is applying our AI model to replace empirical management and verify practical optimization effect. We identify natural break points and get 28 each item and 52 L items verified by 2 chart. Second, result of k-means cluster. All CV data concentrated between 9.2 and 9.5, which means demand volatility of this product is centralized with tiny gap between different varieties, and the clustering distribution is displayed clearly in figure. Third achievement, quantified safety stock calculation. We match the corresponding Z coefficient and service level for 6 categories and compute the optimal safety stock quantity for responsive fabric sample detailed in the table. Then we calculate color demand proportion to carry out proportional replenishment, reduce stock shortage and overstock. Finally, part 4, conclusion. Our research brings 3 core values. First, the model serves the traditional inventory core defect of subjective classification and blend replenishment via objective data logic. Second, it improves warehouse automation and decision accuracy, allowing human-made error under a complex multi-SKU environment. Third, the framework is lightweight and low cost to deploy, highly suitable for digital transformation of small and medium-sized enterprises. More broadly, our method provides a replicable, intelligent upgrading pace for multi-category warehousing in textiles and related industries, promoting cost-effective small logistics developments. That's all for my presentation. Thanks for your listening, and I'm ready for any questions and discussions.
Thank you very much for your presentation. Any more questions, please?
I have a question.
Yes, please.
What is the basis for selecting different Z values? Can those values be adjusted flexibly? Okay, thanks for your question. About this core correspond to target service level determined by balance stock outlooks and inventory holding costs. HX, XY, and HZ are core hot selling fabrics. Stock outs will lead to heavy order loss, so we set higher service level and match Z values. In contrast, LX, LY, and LZ have long consumption and higher shortage costs, so lower service level are adopted to cut redundant stock. In practical application, Z value can be modified freely. Enterprises can raise Z to improve product availability or reduce Z to save warehouse expenses. The system will recalculate safety stock automatically after parameter changes. Okay, that's all. Okay,
Thank you. Thank you for your answer. Any more question, please? Okay, as I see, there are not any new questions. So thank you very much again for your presentation. And now we switch to our next one presentation. Next one presentation number 3366, profile-driven NML detection of electricity consumption behavior in smart grids. As I see presenter is with us, please, you may start your presentation.
Vadim,
Okay, can you see my...
Okay.
Okay. Thank you so much. Good afternoon, everyone. And today I will present our paper titled "Profile-Driven Anomaly Detection of Electricity Consumption Behavior, Smart Grids."
Excuse? Chen Shirui, please.
Yeah.
Time is past, so we can start at 2 o'clock.
Okay.
We have a rest. Okay.
Oh,
Thank you. Sorry.
Oh, thank you.
Sorry for disturbing you. Sorry. Okay.
Okay.
Ready. Have a rest. Thank you. Thank you. At 2 o'clock, we will
so we
start.
have a break, and all the presentation will be continue after the break.
Сейчас мы закончивается. Потом в 2 часа после они начинают. Ничего страшного.
Окей. Да, хорошо, хорошо.
Да, вы сейчас немножко объясняете, отдыхай, и вы отдыхайте.
Да, а потом Андрей, да, будет?
Да.
Вторая часть.
Вы объясняете по-английски сейчас.
So, dear attenders, dear authors, now we have a break, and after the break we will start from the presentation number 3366, and we start 2 p.m. by Beijing time. Okay, so we wait for you after very little break time.
Okay, have a rest.
Have a rest.
Bye.